Hi, everybody. Thank you for the clapping. That was really nice for me to come out on stage, too. Thanks, Dale, for having me, and thanks for joining me today for your Valentine's Day afternoon. I don't know if anybody has said that to you today. Happy Valentine's Day. So as you heard over the speaker, my name is Lindsey, and I am the acting chief of CISA's Vulnerability Response and Disclosure section. It's also, in addition to being a long title, it is also a lot of work. And so I find between trying to say my title, my last name, and my agency in one sentence, and doing the actual work, I have very little extra time. So it's fun for me to be out here today, and I really appreciate it. So as I was flying here, I actually flew here from Idaho, which is really cold today, like -4 degrees. And you find that you both benefit from the body heat of your seatmate and also engage in conversation. So I was talking to the gentleman next to me, and he asked me, what are you traveling out to Miami for? And I said, well, I'm going to talk at a conference. And he said, well, what are you going to talk about? And I was like, well, I'm going to talk about software identity, which doesn't generally make anybody super excited that's not in the software security field. And so I said, he kind of looked at me and he said, cool. And I said, well, what do you do? And he said, well, I manage a fleet of trucks. And I was like, I got this. I know how to do this. And I said, okay, when you manage your fleet of trucks, how do you identify each individual truck? I don't think you have a comfortable family or intimate relationship with that truck, so how do you know that this white truck is different from this white truck? And he said, well, that's easy. We have a VIN number. I have a vehicle identification number. I open up the truck door, I look on the inside, and that's how I track my truck. And I said, well, that's exciting. That's good to know. And I'm sure that there are vehicle vulnerability researchers out there. Maybe some of them are presenting right after me on this stage, and they will refute everything I say right now, so take it with a grain of salt. But so he said, we track based on the VIN number. And I was like, cool. So when a manufacturer finds that a part or component or piece of that truck, whether it's software or hardware, which I realize is not an exact metaphor there, but when your manufacturer identifies something vulnerable in that truck or a security risk, do you have to track it down? And he said, no, they contact me. And I said, well, how do they do that? And he said, they email me, or they call me, or they send me a postcard in the mail, or they fly a balloon overhead that said, I'm trying to contact you about your extended warranty. And I said, that's really awesome, because what that means is that with that VIN number comes some kind of dependency mapping for every single part that's inside of that truck, or that's in the software that's in that truck that makes it run and go and track and do all the things. I don't know if you can tell, I'm not a car person, but cars go and they do and they track and they count. And that's really awesome. But if there's a security vulnerability or a safety issue in your truck, your manufacturer calls you. They find you. They say, come in, have your airbags replaced, or something bad's going to happen. And the liability of that and the responsibility of tracking those dependencies is on the manufacturer. Imagine if the tables were turned, sir, because he was sitting next to me, sir. Imagine if the tables were turned and all the onus for figuring out that risk and that safety, those safety issues was on you. It was on your shoulders. And you had to track your truck, and you had to track every single component and part in your truck. What would you do? And he said, well, my job would be a lot harder. And it's not a perfect comparison, but I argue that it's pretty good for showing the average person that that's kind of what we do in software right now. Because we don't have a universal software identification system that can be used for all applications, we kind of put the risk on the software user to say, you've got to figure out what's in your product. And yes, some vendors and some manufacturers, they do a really nice job of keeping track of what's in their products and contacting their users. But because the way that we use software is different from the way that we use trucks, you can't always get to every user, even when the vendor or the manufacturer is doing the very best possible job that they could. And so that's what my talk is about today, and I'm very grateful for the guy who sat next to me that managed a fleet of trucks and gave me the opportunity to practice that little metaphor. So if you dig into the rabbit hole of software identification at all, you will run into this quote. This is such a big problem in the software security field and in other fields that want to pursue automation, for example, that there is literally a classic quote from the developer, or attributed to the developer Phil Carlton, that says, there are only two hard things in computer science, cache invalidation, and naming things. And you will find this quote in almost every scholarly article, blog post, my presentation about software identity that you go out and find. And I'm sorry William Shakespeare didn't say it, but isn't that a lovely photo of the bard? So you'll find this quote, and that's because, yeah, it is hard. Does it seem like it should be hard to uniquely name software? I uniquely named 2 human beings, so I should be able to do it. And actually, the answer is yes, it's very hard, or I wouldn't be here. And fortunately, there are a lot of people doing the research that really matters and the hard work to figure out what the ultimate solution is. So there are a few problems along the way, though, and a few issues that are kind of universal in this software identification problem set. And the first one is that my talk title is a deception, and I apologize. But thank you. But a name is actually not equal to identity. It is a piece of identity, but it is not equal to identity. It's not a one-to-one connection. So a great example is, let's say that your name is Elizabeth. I like Elizabeth because it gives me a lot of options. But let's say your name is Elizabeth. You may go by Elizabeth on your formal papers for the government, and you may go by Beth with your friends, and Lizzie with your family, and you may have a grandmother that, despite your best efforts, still calls you Betty to this day. But that doesn't fundamentally change the fact that you are that person, that your identity is Elizabeth whoever, right? And so names do not have a one-to-one relationship with identity. And what's complicated about that is that even though we need something that has a one-to-one relationship with your identity, we need a number, a VIN, whatever it is, we still need to be able to have names. We still need the language to refer to things. So for example, I still need to be able to call Elizabeth in one context and Betty in another, and maybe I want to refer to a whole flock or murder of Elizabeths, right? But I also need to be able to individually identify each Elizabeth in that group. And so for that reason, the naming problem is complicated because you're actually answering a lot of different questions. And another example I like of this is, have you ever seen someone who, I don't know if anybody still uses Facebook, but I know my family does. Have you ever seen somebody who on Facebook has some kind of alternate version of their name for their Facebook, right? And the reason that they do that is because their friends may know them as one thing, their family may know them as something. And ultimately, they want to be able to identify themselves in a way that many people who they know and care about will recognize, but not in a way that automated tooling can identify them and scrape their information and put it all in one place. So that's one reason why the software naming problem is hard. That's because name does not equal directly identity. Another reason why the naming problem is hard is because we have this idea, and I may nerd out just a little bit because one of the things that my background introduction didn't say about me is that before I got a master's in computer science, I was a high school English teacher. And I have a background in English literature, and my first love was linguistics. So I love this philosophy of language stuff. So I may nerd out a little bit. But you have this idea of intrinsic naming schemes and extrinsic naming schemes. And I'm going to use a definition provided by the Software Heritage Institute. I would urge you to look at a lot of their documentation. It's very helpful in understanding this space. But essentially, it's kind of a giveaway with the names, right? Essentially, an extrinsic naming scheme is something that is given to you that is not intimately bound to what you are. And in fact, there's a register or registry that maintains the relationship between that name and that thing. So Software Heritage Institute provides a really good example of what this actually is. And I like this one. It's your social security number. Is that an important thing for you to know about yourself? Yes, thank you. Yes, your social security number is really important for you to know about yourself. But I would say the person next to you probably doesn't know. And if they do, sorry. If they do, you got bigger problems. But your social security number, other than being recorded and connected with you in a database, has nothing to do with who you are as a person, who your identity is, or what I would call you every day, or what I would refer to you as in a presentation or a meeting. And so that is called an extrinsic identifier. There is a register, someone or somebody maintains that register, and in some ways, that introduces problems to the naming issue. There's also this idea of intrinsic naming schemes. And hi, Alan Friedman. Intrinsic naming schemes are intimately bound to the thing that you are. And so the example given to us by the Software Heritage Institute is one that is less exciting to me because I nearly failed high school chemistry. But the entire field of chemistry is essentially an intrinsic naming scheme. So does anybody know the scientific name for table salt? Yes, thank you. NaCl, right? Sodium chloride. So named because it is literally made of two things. I'll give you a guess. Sodium and chloride. Thank you. So an intrinsic naming scheme is something that is intimately bound to the nature of the thing itself. It doesn't require a registry. It just requires that everybody using the naming scheme agrees to the rules of that naming scheme. So clearly, we have big issues in the software naming and software identification problem set. But I would say that the bigger problem, and the thing that I'm going to talk about eventually, and I don't have a solution for it, but I would love for you all to recognize the problem with me and come together, is that although we have a lot of solutions for a lot of different problems and a lot of different use cases for software identification, we don't have a global system that takes all of those different use cases and all of those different software naming schemes and puts them together and says, this person that goes by this social security number is named Elizabeth, and she also goes by Lizzie, and she goes by Beth, and she goes by Betty, and sometimes who knows what, right? But all of these things map back to this individual identity. So you might be wondering why me, a vulnerability response person who is constantly engaged in operations and responding at a very, very fast pace to all the new vulnerabilities that come out, including Log4Shell and anything you can imagine, you might be wondering why I care and why CISA cares about such a philosophical problem. Well, I present to you a blog post. If you follow CISA at all on social media, on Twitter, or read our website, you might have noticed this really nice post that our Executive Assistant Director for Cybersecurity, Eric Goldstein, put out last fall called Transforming the Vulnerability Management Landscape. Now, I really like this post because in addition to highlighting the work that we do on a regular basis in vulnerability management at CISA, it also suggests some things that we could do to scale into the future. Now, some of those things we're already doing in earnest. So, for example, we recognize that the number of CVEs published per year just goes up and up and up and up and up and up and up. And we understand that that can easily drown an organization that, for whatever reason, doesn't have a prioritization scheme for responding to vulnerabilities. And certainly, like in the ICS space or the OT space, does not have a way or means to patch every single vulnerability. We hear this all the time, right? And so already we are using an internal prioritization scheme called SSVC, or Stakeholder-Specific Vulnerability Categorization. If you are interested in that, I urge you to look it up on our website. We have made our decision tree public. It's very interesting. There was a talk on SSVC at S4 a few years ago, so there's a lot of material online. I urge you to look up that prioritization scheme. We're also working on putting our advisories out in a machine-readable format. This is something that we've never done before. If you are here, I assume that you have seen our ICS advisories. Anyone? Yeah. So that's, yeah, thanks, thank you. So that's our team. Our team puts ICS advisories out in addition to our SSVC scoring effort. And we are currently working very hard to put those advisories out in a machine-readable format in the very near future. And finally, we are moving towards, and I would say jumping feet first into this idea that vulnerability management should be automated. We are trying to move into the world of automation. It's a scary place, but much needed, and I'll tell you why. As the number of CVEs go up and up and up and up and up, I could not possibly add to my team enough people to manually process all the information that we get. What I need those people for is their specific analysis skill set. I need to be able to automate certain scripted processes so that my people who have real vulnerability analysis skill sets can jump in and do the actual human analysis where it's necessary. All the scripted processes can be automated. Now, that sounds great. I don't think that there is very much controversy in that statement, but it turns out that one of the biggest barriers to automating in that way is the software identity problem. So that's why I, as an ops person, care about software identity. All right, and finally, I would be remiss if I did not include this XKCD comic. I think that many of us have probably already seen this at this point, but if you haven't, please take a look. So this is the reality of the world that we live in, and in many cases, I would argue that it's even more pressing for the ICS and OT space, where a lot of times we don't necessarily have very much visibility into the projects and the code that supports our favorite products. And so we're living in a dependency world where our software has many dependencies on projects that may be dated. There have been mergers and acquisitions that have caused our products to change vendor names, to change product names, to change product versions. You've got project forking and goodness knows what else, and all these things you need to track in order to do real, proper vulnerability management. And we don't even have common software identification that allows us to do this dependency mapping and say, this thing here has these little things inside of it, and these little things are vulnerable, but maybe not in this implementation, and on and on and on. And so if you've been listening, you might have heard some keywords that I said that perhaps implied to you that my next topic might be SBOM. Has anybody here heard of SBOM? Woohoo! That's awesome. So a few years ago, probably there would be, maybe a couple of people. I think it's really fantastic that we have the SBOM pavilion upstairs. I think it's really fantastic that we are talking about this problem now. So SBOM, of course, stands for Software Bill of Materials. And one of my main goals in this talk was not to focus exclusively on Software Bill of Materials, because I would like everybody to see that this software identity problem is a problem for more than just SBOM. It's a problem for vulnerability management, it's a problem for license management, and it's a problem for process automation in general. But I still need to talk about how it's a big problem for SBOM. And in fact, a lot of people are looking into this now and producing and publishing great material on potential solutions. So if you're sitting here, you've heard me talk about vulnerability management, you've heard me talk about SBOM, you've heard me talk about several other things, but you could still be sitting there and saying, I don't think this really applies to me. I'm on a jet, right? Which, like, more power, I get it. But I think that this maybe applies to you even if you think it doesn't, right? So you're sitting there going, is this my circus? Are these my monkeys? Do I care about this? Like, why am I here? So again, if you don't care about SBOM, and you don't care about vulnerability mapping, you don't care what in your stuff has log4shell or is vulnerable to log4shell or not, maybe you care about inventory tracking. Maybe you care about license management, or maybe you care about just general process automation to make your life easier. That is why I would argue that the software identity problem is applicable more than to just SBOM, which is what a lot of if you go out and do your lit review, a lot of the material is SBOM specific, but I argue that there's a greater reach. And then finally, is Jens here? I have to do a shout out for Jens Wiesner. Last year at S4 22, Jens, who is a great partner, BSI is a great partner to CISA, Jens talked about how CSAF, not SBOM, is the solution. And I like that Jens went with a bold title. So CSAF is the Common Security Advisory Framework. It's essentially an agreed upon JSON format for vulnerability advisories. And we agree that machine readable advisories is the next step in the future of vulnerability disclosure. And so we're definitely seeking out CSAF and how we might publish our advisories in CSAF format. But I had to give a little shout out to Jens because indeed software identity also applies to CSAF. So let's dig into some of the software identity solutions that are available right now. And because I wanted to talk so much about the problem space, I'm going to go really high level on the potential solutions. There are a lot of them out there. The three that I'm going to talk about today are CPE, or the Common Platform Enumeration, SWID Tagging, and Purls. And the reason I chose these three is to demonstrate a couple of specific things, which I'll go into for each slide. But I would urge you, each of these has a specification published online, and if you're interested, go look. It's all open. It's all available for you to look at and to research a little bit more. So first I want to talk about the Common Platform Enumeration, or CPE. And CPE is perhaps the most widely known and certainly the most widely used, maybe slightly controversial topic, the most widely used for vulnerability management specifically. The Common Platform Enumeration is interesting. So it's maintained by NIST. It's vulnerability specific, which means that if you know about NIST, and anything about vulnerability management, you know that NIST maintains the National Vulnerability Database. And it tracks all CVEs there. It assigns certain values and fills out certain information about those CVEs. So when a CVE for a product comes up through NIST's NVD, NIST assigns a Common Platform Enumeration, or CPE, to it. In this case, if you remember back to, think way back to when I talked about extrinsic versus intrinsic identifiers. In this case, a CPE is an extrinsic identifier. The CPE dictionary maintained by NIST is the register for the CPE. It is assigned by NIST, and it's tracked in that way. So while this is certainly one of the most broadly used solutions, there are definitely issues with using it, especially for applications beyond vulnerability management. The first one of those issues is that the CPE dictionary itself is difficult to search. If you have ever been there or tried to do it, you would understand why that is. There is one common search bar for every field in a CPE, and sometimes the results that are returned are not intuitive. For example, if you put an identifier in that you'd like to search for, and I won't say a vendor name, but let's say you put a vendor name in that you want to search for, and the results come back as 0. That's all you get as an error message, like 0 results. So it's very difficult to understand if there are actually no vulnerabilities for that vendor, or that vendor doesn't exist, or that vendor name has been spelled wrong because there's no way to do any sort of fuzzing to see if you've spelled Siemens EI instead of IE, right? And so the results in many ways are not intuitive or informative. Another thing that is a little bit problematic about CPE is that it's very product specific. It's very product and vendor specific. And I would argue that when the need for CPE arose and when CPE first came out into the world and had its debut, we needed that. That was the way that we looked at vulnerability management. It was product specific and it was vendor specific. But as we have advanced in our software development world, we have become more reliant on modules and code snippets and functions and packages that are open source or third party. And because CPE is product and vendor specific, it is very difficult to capture a vulnerability at a module or package level in a CPE. So enter the next solution, which I think is also very popular right now, and certainly its widespread use is, or its use is becoming more widespread. Package URLs, or Purls. Now, package URLs are a great solution for trying to identify specific vulnerable packages, software packages. A package URL is a really simple URI string, basically, and it has up to 7 potential data fields that you can use, although only 3 are required, as highlighted here. So it has a scheme, a type, and a name. Those are the 3 required. The others are optional. The scheme for a package URL is always PKG, or package, although it is possible in the future that there may be other schemes that are usable. The type describes the package management ecosystem that the product exists in, so for example, Maven or NPM. And then the name refers to that name of that specific package within its ecosystem. So one important sort of clarification about that is that a package could exist in 2 different ecosystems, and that's okay because that means it has 2 different package URLs. So package URL, I think, has a lot of promise, and it's certainly more useful to the open source and third-party component vulnerability tracking community. And finally, really quickly, I want to talk about the software identification tag, or SWID tag. You may have heard of this. I wanted to mention it because I think that this is possibly a little bit of this is a slightly different format. And I think SWID tags are interesting because they're ISO standards based. They have a lot of support behind them, and yet especially in their original implementation, and yet their use across the industry is super low. And that's an interesting problem because I think it indicates, especially when you compare solutions like Purl and SWID tagging, I think it indicates that there is a need for less management behind the scenes and less documentation maybe, and more of this kind of solving the problem that's immediately in front of us. So SWID tags are interesting. They are provided by the vendor of the product, the supplier of the product. They are created by that vendor specific to that product, and then they're packaged up in the binary and shipped off with the product. The interesting thing about that is that they're version specific, so if you perhaps had a version of a product that has the SWID tag associated with it and you wanted to have some information about the previous versions of that product or subsequent iterations, it would be very difficult to have that. Another interesting thing about a SWID tag is because it is created with the product, if there is like a merger or acquisition that changes the vendor of that product or the name of that product, you might have a little bit of a hard time finding historical data about that. So ultimately, there are a lot of different solutions out there, and each solution is intended for one or two unique use cases and special applications. And while we seem to be able to continue to come up with these solutions for special one-off applications and use cases, I think the really difficult thing is finding a solution that's global, finding a global identifier solution. So when you're looking at a unique use case, one application, you need something for vulnerability management in proprietary products or for license management in proprietary products. You might be thinking about a few factors. You'd be thinking about the readability. Is it readable by humans? Yes, no, maybe so, does it matter? It depends on the application. What's the distribution, what's the production like? Is it just distributed? Is it something that you have to have a register, you have to have a body that's distributing these identifiers, or can I create it, just me at home sitting in my office chair? What's the propagation model? Again, with the register, are we disseminating this in a binary file, or is it a naming tag? What is it? And how precise are they? So this is a good example of how a CPE could be precise to a certain level, but you're still not finding out about whether there's a vulnerable module within that product. So the path forward. Now, I did have some, let's say, minor identity crisis about not being able to come on stage and give you an actual solution. That really bothers me. As a person who does vulnerability response ops, I don't want to come up here and admire the problem with you, because I would like to give you a solution that you can make a decision on. However, there is not currently a solution. Now, at CISA, especially in my ops role, I have run into this problem enough times that I am tired of running into this problem. I would like to find a solution for the global identifier problem, and I would like to move that path forward. So I mentioned this sort of like crisis of coming on stage and not having a solution for you to a friend of mine. And she said, Lindsey, it's not about being the person with the solution. It's okay, we can't always do that. It's about being the convener. And we can all play that role sometimes, and CISA certainly would like to play that role. We would like to convene interested parties. Do you have a stake in software identity? And if so, I would like to hear what it is. I want to understand your perspective. My lit review on the internet can only go so far. My reaching out to my network and asking them how they feel and what their input is can only go so far. So what I would propose is that CISA can act as a convener for this problem, and try to find and identify what the real ultimate solution might be to finding a global identifier system that works for every application. If you'd like more information, you can go to CISA.gov. If you would like more information, in particular about our machine readability effort and about our SBOM effort, you can go to www.cisa.gov/SBOM. I like to call this my 1-800 call Alan Friedman and his team and not me slide. But if you would like to participate in this work, if you would like to give your input to CISA, you can email techassurance@cisa.dhs.gov. I know the 3 to 10 people who staff that inbox, and I am happy to facilitate an introduction and allow you to give some excellent feedback so that we can convene together and find a solution for this problem. Thank you so much, and happy Valentine's Day.